All right, hey everybody. Lesson 11 now. Lesson 11 is where we were verifying identities. I already made a video on these. You guys might remember. This is the one I actually posted for you to watch. So if you're interested in seeing those problems again, just pull up that other video, kind of a short one. We did these in class, so whatever. You then had a big bank of questions, and for homework by tomorrow, you're supposed to be doing the evens, I believe is what we said. So do 2, 4, 6, and 8. And then do 2, 4, 6, 8, 10, and 12. That's a lot of problems, and I feel like in class we must have got to every one of these. I mean, I feel like we got to a lot of them. So I don't think I'm going to do any of them. If y'all weren't paying attention in class, then alright, that's going to come home to roost today. I'm not doing any of these. I found some other problems online, and we'll do those, which is good, because if you're here to learn, then I'm going to show you a problem. Click pause, try the thing, see how it goes for you, and then I'll explain it. So anyway, let's do that. And I don't know, maybe some of these are the same, but they looked fresh to me. So here you go. Here's some questions I found. So this guy says, show that cotangent of 2 alpha is 1/2 of cotangent minus tangent. Alright, let's try. I'm down to try. Let me make it bigger. Maybe about that big. Sure, that's what we're doing. So the first thing I'll say is, you know the cotangent is the reciprocal of tangent. So if you're trying to get to cotangent of 2a, then you're basically just trying to get to 1 over tangent. And let's not forget the tangent of 2 alpha. That's 2 tan alpha over 1 minus tan squared. So basically, in this identity here, you guys should be focused on trying to get to 1 minus tan squared alpha over 2 tan alpha, because from there you could definitely say, all right, that's 1 over tan, which is cotan. So we're hoping to get there, and it doesn't seem like it should be too bad, right? So okay, again, I would say this side is the simpler side, so leave that side alone. Operate on this side instead. We got a 1/2. We got a cotangent, which is cosine over sine. We got a tangent, which is sine over cosine. If I generate a common denominator, I'm supposed to switch colors. You know what? I'm not going to switch colors. Stick to one color, but we'll put a little line. That line tells me we're starting a new line. Alright, if we get a common denominator, then we're going to be looking at cosine squared minus sine squared all over sine cosine. Okay. You know what? So seeing what I'm seeing, I'm gonna change the process. I know I said some junk over here about how if we're trying to get to cotangent, then maybe we want to be looking for the reciprocal of tangent. I don't think that anymore, because now that I see cosine squared minus sine squared, that's cosine of 2 alpha. So if we're trying to get here, then we could also be thinking of cotangent of 2 alpha as cosine of 2 alpha over sine 2 alpha. And we've already got that, because they very generously gave us this factor of 1/2, which is going to pop a 2 down here into the denominator, and then 2 sine x cosine x is sine of 2 alpha. So actually this is a really simple identity to prove, it turns out, because, well, like I said, up here in the numerator, we can already turn that into cosine of 2 alpha. Is this supposed to be alpha? Why are these all x's then? Alpha, 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 alpha. So that's cosine 2 alpha. Now downstairs, I'll take the time, I guess, just to show that 2 will go in there. 2 sine alpha, cosine alpha. Okay, On the next line, of course, we'll turn that into sine, and on the line just after that, we'll have cotan and we'll be done. I hope this felt easy to y'all. Cosine 2 alpha, sine 2 alpha, and so now that's cotan of 2 alpha. Alright, again I'm being lazy. Bump bump. These are really supposed to stay equations all the way down. We can just call this left-hand side, left-hand side. But you should be writing something, some kind of placeholder that lets me know that you're actually operating on an equation. Left-hand side, and then finally at the bottom, give me my cotan 2 alpha equals cotan 2 alpha. There's the end of the road. We did it. So yeah, that's different. We didn't see that in class ever, so hopefully that made sense. Let's do another one. I might have a few of these. I don't know. Did we see this one before? I don't know. Maybe we did. Anyway, again, I'm kind of expecting that you're gonna pause the video here and do this yourself. There's literally no point in just watching me do it because this isn't even a homework problem. So I hope you'll take a moment and try it for yourself. Do I know what to do here? Not rightly sure. I don't know. I'm thinking multiply through by the conjugate. A whole mess of stuff will cancel. Let's go for it. Conjugate or just get common denominators? I don't know. Let's go back to the previous problem. We basically had that same thing, a cotan minus a tan, right? And I'm seeing that again. Cotan minus tan is my numerator. So we already know that if we were just going to subtract those, turn them into this, get common denominators, blah, 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 then we could turn that into a cotan. Is that good? Seems okay. Maybe that's the play then. Just get to cotan. Sure, I'm going to do that. Forget about any conjugates or anything. And again, I don't know. I don't know if this is going to work for sure. But I would break this down. Let's just do the whole sines, cosines things. So this will be cosine beta. Sine beta. Cosine beta. Sine beta. This is going to take up a lot of room, I think, too, but oh well. Cotan is going to be cosine beta, sine beta, plus sine beta, cosine beta. Alright, is this going where I want it to go? Just in the interest of not running out of space real fast, I'm going to work to the side. I never work to the side. I love working down, but we're going to do some side movement, I think. Alright, so we already saw that this can become cosine squared beta minus sine squared beta all over sine beta cosine beta. Our denominator will be cosine squared plus sine squared. But with the same denominator. Alright, so we know that we can kill those denominators. Yeah, okay, right, we're done. So this is now cosine 2 beta, just over 1, which is cosine 2 beta. So another easy one? Maybe y'all agree that was easy? Yeah, hopefully you thought that was easy. We can do another one. How's this look? This one might feel a little weird. Let's see what you guys see. If I see 4 sine alpha cosine alpha, I'm breaking that down. That's 2 times 2 sine alpha cosine alpha, because that's going to allow me to use my double angle, turn this into sine of 2 alpha. I'm trying to get to sine of 4 alpha. Let's see how we do that. This other guy, 1 minus 2 sine squared alpha, I hope you can tell that's just straight up cosine of 2 alpha. Alright, so this is 2 times sine of 2 alpha times cosine of 2 alpha. And that's it. We're done again, because if you see this, you've got 2 sine cosine. That's double angle sine again. And so it'll be the sine of our angle doubled. And 2 alpha doubled would be 4 alpha. So we're done. Boop. So maybe I found a bunch of problems that are maybe a little too easy. Let's try another one. I don't know, or maybe they just feel easy to me because I've actually been doing them a lot and I've gotten a lot of practice, and maybe you guys will do a lot of practice and be ready to. Alright, let's try this guy. This might be the last one too. But don't forget, you got the other video to watch, the older video, the one that you were supposed to watch as the lesson opener. You can go back and be looking at those too. But I gotta get to the solving equations one tonight too, so we gotta call this eventually. Okay, we're trying to turn this into sine of 2 theta. So I will do what I will always do anytime I get the chance, which is just turn this stuff into sines and cosines. So this is 2 sine theta over cosine theta. This is minus 2. This is a sine, so I'm going to combine it right now to get a sine cubed. I don't think I lose anybody by doing that. We'll have a denominator that's cosine, which is good because now we can combine those. This is now 2 sine theta minus 2 sine cubed theta. Just all over cosine. I guess I'm factoring out 2 sine. Yeah, I see where this is going already. So if you factor out 2 sine theta, then you're left with 1 minus 2 sine squared. Cosine. Actually, maybe I don't know where this is going. Because that's cosine. I'm just keep plowing ahead. Alright, this is 2 sine theta. 1 minus 2 sine squared theta. That's one of the double angle cosine forms for us. So that's cosine of 2 theta. And this is supposed to be all over cosine. Thought I had an idea from here. Sine of 2 theta. Okay, I paused the video so you guys wouldn't have to listen to me bumbling and stumbling, but I see it now. I made a mistake. I factored out a 2. That 2 right there, we factored that out. But I left it in, so get that out of there. So I'm looking at this and thinking it's the double angle identity, but it's not. That's just a Pythagorean identity that's going to allow us to get a cosine squared. So that's what this is about to be. So that's just a cosine squared. which means now that we're done. We can cancel this cosine with one of these cosines. Let's go up to the top. We now have 2 sine theta cosine theta, which is sine of 2 theta, which is of course what we wanted it to be. So the left hand side does indeed equal that. So we're done. All right, I was being lazy. Again, you really have to show that, so make sure you do. All right, was that a hard one? I don't know. It tripped me up for a second, but only because I think I was screwing up. I think that's probably not too tough of a one to do. Yeah, I don't know. Hopefully you're fine. All right, here's one more, 2 more. I'm gonna do them both, so maybe you guys need them. I don't know. All right, here goes. All right, what do you know? Well, the numerator is nothing. The denominator is secant. I'm going to go ahead and make that change. So if the denominator is secant squared, then on the next line, this is really going to be 1 minus tan squared. And secant is really 1 over cosine squared. So I could just be multiplying by cosine squared. I don't know if that's a jump too far. I'm going to call that a jump too far. I'm going to say we should include the intermediate step where we actually show what that is. So that's 1 over the cosine. Which means now if I'm dividing by 1 over cosine, I can just be multiplying by cosine squared. That's going to distribute in. So you're going to get cosine squared. And I want to say you guys don't have to show this work anymore. I mean, you guys know tangent is sine squared over cosine squared. So to see this get multiplied by cosine, to imagine the cosines canceling and you get sine squared, I want to believe that's fine. You guys know that's what would happen here, right? Do you got to show that intermediate step? I want to say no. But guess what? We're done now. So maybe we should just show that step since we're done, because this is cosine 2x. And we were trying to prove that it was cosine 2x. Bing. So we did it. So we'll bring this down. Left hand side, left hand side, left hand side. Till they're the same, and they're the same. So there you go. One more. I feel like it looks like something we've already done, but that's okay. Alright, in the numerator, there's nothing we can do but expand it. At least nothing I can think of. So 2 sine x cosine x. In the denom, I don't know what I want in the denominator, but there's a sign down there. So I'm going to express this guy using all signs. So 1 minus 2 sine squared x. I guess I'm doing that, and then I'll add a sine squared x. And this is supposed to equal 2 tan x. Oh yeah, I already see this is working beautifully. So our numerator is 2 sine x cosine x. When we add the 2 sine squared x and a sine squared x, we can combine those. You just add the coefficients. So instead of negative 2 of these, we add 1. We now just have negative 1 of those. So it's 1 minus sine squared. And that, of course, means that we can just use a Pythagorean identity. This will now be cosine squared. And it's supposed to equal 2 tangent of x. And I can now cancel a a cosine with one of these cosines, giving me 2 sine x over cosine x, which of course is 2 tan x. And so in the interest, just because I'm running out of space, we'll work to the side. I'll make it like an arrow here or something, showing that we're moving over. This is our simplified expression. And does it equal 2 tan x? It does. So we can definitely say that we're done. All right, so those are your identities. Were any of them terribly taxing? Not really. I think the ones from our homework might have been a little tougher. But I don't know. You should be all right. So see me in the next video. We'll solve some equations. I'll meet you over there. Bye.